So your final is cumulative. It's on Canvas. It has the same setup as exam 1 and exam 2. It's available from this Friday to next Friday. It's open tomorrow at 6 in the morning and it will close on the 17th at midnight. This test is 10 questions. Every question is worth 10 points. You need to work on it over that finals week, but once you start the test, there's no time limit. Unfortunately, there's no save for later option, so once you start the test, you need to submit the test, but you have multiple attempts. I'll give you the highest score depending on how many times you try the test. And if you show work on a problem, it could help you get more points for that problem. Today is the last class meeting. We don't meet next week. So I'm going to double check, but today is the last day of instruction, but the 17th is the last day of the semester. It should be on the CSUS academic calendar. I've checked it before, but someone was kind of asking about it earlier, so I'll check again. But this is the last day to turn in any assignment. After that, I'm going to post the grades and we can't make changes. Then it'll take a few days for those grades to show up in your student center. So be a little bit patient with getting your final grades after the 17th. All right, I'm going to go ahead and start doing the rest of the review. And at the end, if you have questions, let me know. We're going to start with factoring. Yep, 4x. 4x squared minus 6x minus 10. I suggest starting with taking out the greatest common factor. So you can factor out 2 from every term. And then on the side, I'm going to factor what's in the parentheses, and I like to use a grid, but you can use whatever method you choose. Any of them, I think, I'm pretty sure, requires guess and check. Okay. Make some space over here. Okay, in this part of the grid, you pick two numbers that multiply to 2x squared. So I'll try 2x and x. On this side, two numbers that multiply to -5. Like 5 and 1, or maybe the other way around. And then you need a negative sign. We'll try maybe here. Then we cross multiply. X times -1 is -x. Then this way you'd have positive 10x. Add the sides together. If you get the middle term, then you found the two factors. If not, we'll have to guess again. So I got 9x, and I want -3x. So we'll just try another guess. We keep the 2x times x is 2x squared. And this time we'll try 5 and 1. Add a -5 with a -5x and the positive 2x. I could get that -3x. So again, you add these sides together. And it's -3x. So we went from here, factored out 2. We factored 2x squared minus 3x minus 5 into 2x minus 5. X plus 1. So you take the top row, multiply with the bottom row. And then that's your, it's called a quadratic or expression fully factored. Right, we're going to do one more problem where we factor x squared. Add x, subtract 30. I'm just going to copy this down. Need kind of space on the side, so scoop. On this side, two numbers that multiply to x squared, you would pick x times x. Let's see. Let's list out possible numbers to choose for two numbers that multiply to negative 30. Let's say you could pick -1 and positive 30, or the other way around, 1 and 30 with a negative sign somewhere, or 2 with 15. Also need one of those numbers to be negative. We do 3 times 10 is 30, and put a negative sign somewhere. 6 times 5. And then pick one of them to be negative. Let's try 6 times 5. I want this middle term of positive x. So if I put the negative sign here, this should be the right guess. Multiply this way, negative 5x. And then add the sides. Side is positive x. Okay, so what we did was took x squared plus x minus 30 and factored it. Into x plus 6. Multiply it with that next row, x minus 5. Okay. Next, we talk about inequalities and then finding the solution set and writing it in interval notation. Let's start with negative 2/5 x less than or equal to 4. Okay, let's just copy down the problem. Negative 2/5 and less than or equal to Okay, the goal is to isolate x. Let's start by taking care of the negative sign. We could multiply both sides by -1. And if you ever multiply or divide by a negative number, you need to flip your sign. Okay, from here to here, change this around. Now I've got a positive 2/5 x. Greater than or equal to -4. Okay, let's take care of that fraction by multiplying both sides by 5. Okay, that's going to leave 1 times 2x, which is 2x, greater than or equal to -20. All right, divide both sides by +2. So when it's a positive number, you don't have to worry about changing the sign around. It just stays the way it is. So solutions are values of x that make this statement true. The solution set is every value of x that makes the statement true. And I think it's easy to find that set by drawing a graph. That's the way I like to find the set. And then we'll write that set in interval notation. Let's put -10 on this graph. We will include -10 with a solid. And you could test some points, or, well, let's just test some points. So you could pick a number less than -10 and a number greater than -10. If it's true, we will shade over that value. If it's false, we don't shade over that. Let's try -15. All right, you're putting it into this inequality. All right, is -15 greater than -10? No, it's less than -10. Is -15 equal to -10? No. So this is a false statement. So we're not going to shade on this side. Other values on this side would give you false statements. Okay, let's try a number greater than -10. 0. Okay, 0 greater than or equal to -10. Yes, it's greater than -10. So you want to shade over this and shade towards positive infinity. Okay, the set starts at the smallest value, goes to the larger value. And I know it can be tricky to type these sets sometimes, so just do your best, or you can ask for help if you're having trouble finding the right symbols. start at -10, include it with a square bracket. Go to positive infinity, which you can find the symbol or you can just spell infinity. And close it with a parenthesis. Okay, in Canvas, there is a part where you can insert a math equation and find these symbols. I think also your keyboard should have a place to put in a square bracket and parenthesis. Or if neither of those is really working out, you can just kind of describe the set to me. I'll understand what you're trying to say. Okay, let's do one more. We will have an inequality that we will solve and then write the solution set in interval notation. Okay. 2x minus 4 less than negative 3x minus 1. Negative of 3x. So there's different ways to solve most math problems. What I did first was distribute the negative sign on this side. So negative 3x plus 1. Okay, and we want one value of x. So we could add 3x to each side and take care of that. Okay, we're just copying this. And then on this side, we have 5x minus 4. Less than 1. I would add 4 to both sides. Okay, with 5x less than 5. We would then divide both sides by 5, and then you've isolated x. Over 5 is 1. 1 times x is x. And it's less than 1. Okay, To get the solution set, I like to draw a graph. I'm going to place 1 on the graph, and we do not include 1, so it will have an open circle. Okay. You need values of x that make that statement true. Like 0 is less than 1, -2 is less than 1. Going this way, you have values of x that make the statement true. You could use test points if you want to. I'm going to put the solution set in interval notation. You go from the smaller value, which is -infinity, to the larger value, which is +1. And we're not going to include either of those in the set. This isn't really a number, so it's not included in the set. And this number is not included in the set because there's a strict inequality. Again, if you can't find the symbol for infinity, you can just write the word. Both negative and positive infinity will always have a parenthesis on the side. We're going over to +1. And don't include that one either. Okay. I'm going to switch to another topic. It's working on simplifying radicals. I'm going to start with the simplify. Huge root of -72. A to the 4th. B to the 15th. Okay, just copy down the problem to get started. So the first reminder is when you have an odd root and a negative sign under the root, you can take the negative out from under that root. Okay, next thing I would do after taking care of the negative sign is factor 72. It's 2 times 36. I wrote this as 6 times 6, and each of those is 2 times 3. Okay. 72 is 2 to the third times 3 squared. Right, I'm going to start to work on this A and use exponent rules. I want to have an exponent that matches the root. So I'll take A, multiply with A cubed, which would be A to the fourth. And I want something similar for B with that power of 15. I could write it as B to the fifth and then cubed. Still have that negative sign. I can bring out this 2 since its power matches the root. Same with this A cubed. We'll bring out A. Multiply it with that negative 2. And same for B to the fifth. Okay. And then under the cubed root is this 3 squared, which is 9. Since its power is less than the root, it's not going to simplify further. It stays like that. And this A right here also stays under the root. So we're going to do a few of these. And I want to point out kind of a shortcut. So you can take your root and then see how many times does that number go into, like divide into the exponent. 3 goes into 4 one time. So you get that value. Then you have a remainder of 1. So that remainder stays under the root, the cubed root. Same for how many times does 3 go into 15? 5 times. And there's no remainder. There's no value of B left over. Okay, so we're going to take another radical and simplify. So this time it's x, it's a square root. X to the 8th times y to the 12th over 4. So there's a few things we need to work on. First, you can't have a fraction under a radical sign. That's part of simplifying the problem. Also, we need the power to be less than the root, which if there's no root written, it's a square root, in order to be fully simplified. So we're going to work on these variables, and I'm going to use exponent rules, and I'm also going to factor 4. Actually, before we even do that, there's a rule for division. If you have the root, this numerator divided by that denominator, we'll have the square root of the numerator divided by the square root of the denominator. Okay, so I want to have a power of 2 to match that root 2. So we'll write x to the 8th as x to the 4th squared. Same kind of thing for y to the 12th. I can choose y to the 6th squared. And so for 2 squared, square root of 2 squared. Okay, so the root and power match, which leaves an x to the 4th. Same with this root and power, we'll get y to the 6th. And then that root and that power will leave 2 in the denominator. So again, let's check out kind of a shortcut. You can look at the root, see how many times it goes into the power. 2 goes into 8, 4 times with no remainder. How many times does 2 go into 12? 6 times, there's no remainder. And then we took the root of 4. I'm going to do one more simplifying radicals type of problem. This one is a 4th root of 48, x to the 14th. And then multiplied by y to the 23rd. Okay, let's do script. I will go over and factor 48. Let's try 2 times 20. times 12. It's 2 times 6. It's 2 times 3. So it's 2 to the 4th times 3. Okay, to work with x to the 14th, I want to somehow have a power 4 and that would match my root 4. 4 goes into 14 3 times with 2 left over. Similar thing for y to the 23rd. How many times does 4 go into 23? 5 times with 3 left over. Go ahead and take out this 2. That power 4 matches the root 4, which leaves this 2 outside of the root. 3 has power 1, which is less than the root, so it's going to stay underneath the 4th root. Okay, with x to the 12th, I can write it as x to the 3rd to the 4th, or x cubed with power 4. Then there's my x squared. Y to the 20th is y to the 5th with the power 4. Then you have that y cubed multiplied on the end. So I already brought out 2. I could do the same thing for this x cubed. And the y to the 5th. Multiply all of that together, and it's multiplied with the 4th root of 3 times x squared times y cubed. Check, we got 2 x cubed y to the 5th times the 4th root of 3 x squared y cubed. I'm going to move on to solving an equation for x, and we're going to use the square root property. With 3x plus 4 squared. Equal to 25. Okay, so I'm just going to copy this down. I'm going to actually put some space right here. Okay, to take care of that power 2, I could square root both sides. And when I do that, we'll put a plus or minus sign in front of this root 25. Okay, that way the square root and power 2 will leave 3x plus 4. Equal to plus or minus a root of 25, which is 5. And we're going to set up two equations. First one is 3x plus 4 equal to positive 5. Okay, solve for x. So you would subtract 4 from each side. And 3x would be equal to 1. Sides by 3. Okay, it's just one solution. There's another solution from letting 3x plus 4 equal negative 5. Okay, and then solve this equation for x. And divide each side by 3. Get x equal to negative 3. Another solution. Okay, and then I've got one more problem using the square root property. Solve for x. Sorry about that. Set this here. Okay, is x plus 1 squared equal to 36? I'm going to square root both sides and put a plus or minus sign in front of the root of 36. Okay, so we're at x plus 1 equal to plus or minus 6. So we'll get two x values, two solutions. First one where x plus 1 is equal to positive 6, and one from getting or letting x plus 1 equal negative 6. Right, we're just going to subtract 1 from each side, let x equal to -7. Almost done. There's 2 more things to talk about. Functions and exponents. Let f be a function such that f of x, so you input x and will output the whole thing f of x, which is x squared plus 6x plus 1. Okay, we want to find f of -1 and f of +2. So you input x equal to -1. And you get out -1 squared. We're going to add 6 times -1 and then add 1. Okay, -1 squared is 1. And then this is -6, and we add -6, we're going to subtract 6. And then at the end, we add. So we've got -5 plus 1 is -4. Next part is to get this f of 2. So we input x equal to 2. See what the output is. Okay, 2 squared is 4, and then add 12, and add 1, 17. So So we didn't get a lot of time to spend on functions. It would have been nice to maybe do 2 weeks of just all functions. But I want to just start to talk about the notation. So we put in x equal to -1, and we got out f of -1, which is -4. So one of the points in the graph of f is -1, -4. Another one, we input 2, and the output is 17. And this is your x and f of x, which you could call x and y. Anyway, both of those points are in the graph of f. Okay, one more function. We're going to call this function g. Okay, such that g of x g of x is with negative of x minus 3 squared plus 1. You're going to get or find g of 0 and g of -2. Okay, let's start with g of 0. We put x equal to 0 and send it through the function g. Negative 0 minus 3 squared. So it's a negative of -3 squared plus 1. This -3 squared is 9. And then there's a negative sign out front. And I got -8. So if you input 0, you're going to have an output of -8 using this function. Okay, g of -2 means put x equal to -2 and send it through the function g. It's right here. It's negative of -2 minus 3 squared plus 1. Okay, so you've got that negative sign. And then in parentheses is -5. I'm going to square that and add 1. Okay, so this part is 25, but then you have this negative sign right there. It's negative, a negative of 25 plus 1 is 24. Okay, we have one more type of question to go over. It's about exponents being unique. Okay, we're going to use 3, and it has a power of x minus 5. And is equal to 3 squared. So I'm just going to write down what I said earlier. Exponents are unique. So you get the same base 3. You have to have the same exponents. This has to equal that. Okay, for this to be true, you have to have x minus 5 equal to 2. And then we can solve this equation for x. Add 5 to each side and have x equal to 7. Okay, I think this is our last problem, and then we'll stop and see if you have any questions. But it's another solve for x. Okay, we have for, yeah, we're going to use 4 to be x minus, to a power of x minus 5. That equal to 64. Okay, so there's 2 ways to do this problem. There's one way to do it where I got both sides to have base 2, or you can have both sides with a base of 4. I'm going to show you how I solved the problem using the same base of 2. Okay, so I'm going to start with factoring 4. So 4 is 2 times 2. So we're replacing 4 with 2 squared. And then you keep that power x minus 5. Okay, we'll go back over here and factor 64. It's 2 times 32, which would be 2 times 16. 16 is 2 times 8, which is 2 times 4, which is 2 times 2. So I got 1, 2, 3, 4, 5, 6. 2 to the 6th is 64. Okay. On this side, when you have this power to a power, they'll be multiplied together. So 2 has a power of 2 times x minus 5. Okay, now that I have both sides with base 2, the exponents need to be equal to each other. Okay, and then keep on solving this for x. I divided both sides by 2. And then add 5 to each side. Okay, that's the end of the examples for the final exam. Everyone in the meeting, you can stay and ask questions after we're done recording. And I just want to say thank you guys for a good semester. I'll send out a reminder on email and an announcement when you need to be working on the test, which is next week during finals week. Good luck on your finals and have a good winter break. Awesome, thank you.